everybody loves pictures, and it's important that you not only understand how to read them, like we were talking about in the last video, but how to create these pictures of data. So let's check it out. First up are stem and leaf plots. These are great for a couple reasons. They keep the original data, so you know every single data point. It's not just generated into some interval. And it's a great method for ordering your data. So what you do is this. You have your stem on one side and the leaves on the other. So I'm going to have my stems represent the number of tens. So my lowest data value is that 11 here. So I'm going to start with 1, meaning 10, and then 2. The leaves are the numbers that are in the ones place. So oftentimes what I do is I just kind of lightly cross off the numbers that I put in. So I'll do the leaves, and how about this pretty color here, or the leaves. I would use green, but just in case I've got any red-green colorblind, we won't do that. So here we are. I only have one data value in the tens, so you just put that 1 right there, and our key is that this equals, so we could say right here, our key or legend, we can say this is equal to 11, and we're talking about percentages. All right? So, how many values in the 2s do we have, or in the 20s? So I'm looking through my list, and all I see is 25, so I just put a 5 right here. You guys get the hang of it? So why don't you go ahead and pause the movie and see you create the rest of the plot and see how you did. Don't forget that if a number's repeated, you keep all instances of it. And if you want, you can just go along with me. So 30s, I think we only have 1, and no, we have 2 in the 30s, I think. Let's see. We have 37, and we have 38. And then the 40s, I know we have a 43. I saw that hiding there earlier. And that's it for the 40s. In the 50s, I thought I saw, yes, a 54. And then going through the rest of the data, I see this 55 here. And then no other 50s. And in the 60s, we will have, all right, a 62. We have what's the next one? A 66. And then I did see a 67 somewhere, I thought. Here we are. And any more? Yes, a 68. And then in the 70s, so I see a 77 here. That's kind of high, so I'm going to make sure, yep, there's a 70. And then I saw a 75. And what is next? A 76, I think I saw. 76, and then 77, and I saw a 70, is that it? 77? It's definitely a 79, and I think we're good to go. All right, so the 80s, there's an 82 here. Let's see if there's any smaller one. Yep, I see an 81. Then I see that 82. And next up, 85. I see an 85. And there's another 85. And then we get to our 87. and 88. There's one, and there's another one, so we repeat it. And I believe that's all of the 80s. 90s, we have 91, another 91, a 98, a 99. Whoops, what was that, a 99? Yep, okay, 99. And then we have one of 100. Okay, so this is our stem and leaf plot. And if you take a look at it, I mean, let's just kind of get a feel for, I mean, do you see that if you sort of drew a distribution, it would look sort of like that. So just visualize rotating this 90 degrees clockwise, and keep that in mind as we're going on through the other items. Okay, so here we go. Let's just sort of recap what we did. We created 2 columns, right? One for the stem and the other one for the leaves. We wrote the stems in the first column in numerical order, and we did that how many times? Good, only one time. And then we wrote the leaf values in order next to each of their stems. So we want to represent all of the leaves. We then made a made a legend or key, whatever you want to call it, so that our plot is clear. To find our intervolar class, we need to take into account a couple of things. One of them is the range of our data. So we'll go more into depth of the range of our data, about the range of our data as we go on to spread. But long story short, in order to find the range, you just take the max value or max data value, and you subtract from that the minimum data value. So in our case, what do we have? We have 100, a score of 100 was the max, and a score of 11 was the minimum. So this has a result of 89, and so 89 is our range. Now, here's where we want to decide how many bars we want in our histogram, or how many I'm kind of jumping ahead, or how many classes that we want in our frequency table. So they're kind of intertwined, those thoughts. In general, one uses 5-ish classes for a small data set, which this is. If you have a very large data set, you might use, up to 20, but it's really left to your judgment, right? So we're going to go ahead and we're going to use 5. So in order to find our class width, all we need to do is take the range and divide by the number of classes. Well, in our case, we will have 89 divided by 5, and that ends up being exactly 17.8. Well, as you see, these are all whole numbers, right? So just for ease of computation, I'm going to call my class width 17.9, because then it'll be consistent. It'll be the same number at the right end of each class. All right, so you'll see what we're talking about. So here we go. Let's do it. First of all, let's make a table. And what we're going to do is we're going to do kind of a combined frequency and relative frequency table, which is what you often see in the real world. You start out with the class and leave some space. Then you've got your frequency. And the frequency is just the number of data values that are contained in that class. And then go to relative frequency. Relative frequency just basically means a percentage. So it's the percentage of data values that are in a certain class. All right, so relatively straight box here. All right, so now the other thing to decide is where do we want to have our beginning of our histogram. So oftentimes what people do is they start with the minimum value. So what was that minimum value again? Beautiful, 11. So start with 11, right? Why don't we say 11.0 just to be consistent? And we're going to add 17.9 to that. And that will give us a result of 28.9. Cool so far? So let's go ahead and do all of our classes before we do our frequencies in case we make a mistake somewhere along the line. The next class would start then at awesome 29.0, and it would go to, if you add 17.9 to that, we would get to awesome 46.9. Now, continuing, you can go ahead and work ahead faster or pause and then check yourself. Okay, so now let's get our rest of our table filled in. These look good. How'd you do? Awesome. Alrighty, and now let's just fill in the spaces. So we've got here, if you were counting how many of our data values are between 11 and what was it, 28.9? So do you see that I'm counting the 1 and the 5 for the leaves that are by the stems 1 and 2? And so we have 2 data values there. Now we'll just complete the frequencies. Between 29 and 46.9, we have nothing left in the 20s, but we've got 1, 2, 3 data values that are ranging between 29 and 46.9. All right, continuing. Why don't you go ahead and try it yourself, pause the movie and try it yourself and see how you do. right, how'd you do? Awesome. Now let's go ahead and take a look at the relative frequencies for each of these classes. What we're going to want to do actually is add another row below. And here I'll just write in total. And what we want to do is we want to sum these. So if you add up our frequencies, we end up having 28, which is good because we had 28 data values. And then, so our relative frequency should sum to approximately 100%. Okay, so we'll make sure that happens. Now, to find each individual relative frequency, you just find the percentage. So if you recall, to find a percentage, I'll work on the side here. For the first class, there are 2 scores in that class out of 28 scores, and we want to multiply that by 100%, which is equivalent to 1. So it turns out when you do that, you get approximately 7.1%. Okay? So continuing, we'll have 7.1% for the first one. The second one ends up being 10.7%. So you go ahead and do these on your calculator and see if everything matches up for you at the end. Okay, so double checking that if we sum these up, we'll end up with the actual sum for all of these ends up being what? So we would have 0.9% here, and then that would be 1929. That would be 99.9%. And do you see that that is indeed approximately 100%? Groovy? Okay, so let's summarize what we just did. We decide on the class width, and again, that should be the same for all classes. And then we want to decide on the lower and upper class limits. This is often the minimum and maximum data value, respectively, or the nearest logical value to keep the same class width. So if you see, I started at 11.0, I ended it at 100.9, so we could keep that same class width. And then make a table of all data values that fall within each class. Groovy? Awesome. All right, so a histogram summarizes data by class, and it's a great way to see how data is distributed, what it looks like. So all we're going to be doing is we're going to be looking at our table, right, and making our histogram. So a histogram is used with numerical data, continuous data. So let's go ahead and make our chart here. So you're going to have 2 axes. So the vertical axis is often the frequency count, and the horizontal axis is where your classes are represented. But it can be either way, depending on how you want your histogram. In fact, JMP, I think, defaults the other way. So here we go. The largest number of frequencies we have are 10. These frequencies are discrete numerical values, discrete, because it's a count, right? All right, so again, these are the frequencies, or frequency count, right? And over here, this part represents the scores, right? Because that's what the classes are. They're groupings of scores. So here we are. We're going to have, I'll just do kind of like a 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, right? So here's 100, here's 80, 60, 40, 20, I'm just going by tens here, or by 20s, I guess. Now, one really important thing about histograms is you have to connect the bars because we're dealing with continuous data. So let's do it. I'll go ahead and you can even, in the programs, you can make them all different colors. It's really pretty cool. I'll just do sort of a basic one here. So here we go. We have one class that goes from 11 to 28.9 from our table. And so 11 will be about here, and 28.9 will be, about here-ish. So in that class, we had 2 data values. So I go up here to 2 and across and then down. I've got my first bar. All right. Now remember, these all stay connected. We've got this continuous data, and we're going now from 29 to 46.9. So here we are. 46.9 is going to be, this would be 45, so it'd be about here. Maybe a little further over. I know my scale is not very perfect. So now we have 3 of those. So if I go up just a little, maybe a little bit more, and then over and down, I've represented the next class. So again, you kind of shade them in. And then our next one goes from 46.9, or 47 rather, to 64.9. So again, 64.9 will be about here. And there's 3 of those again, so we'll just go at that same height. And then down. Oops. One more try. All right, and then we'll shade that in. And we'll see it's real easy once you have everything set up. So then our next one jumps up to 10, right? So then the class width takes us to 83.9. So that'll be around here. And then 10 is going to be way up here somewhere. Actually. And going across. And I'll make it a little nicer here. And then shading. Got that guy. Okay, and then our last class goes all the way to 100.3. So it's really very close right here. Very, very close. And that's not good. All right, and we're good to go. So my scale wasn't the best, but that's okay. We're all good. So this is how you would make a histogram, and a relative frequency histogram is all the same, really, except what do? We do our vertical axis would be from 0 to 100%, and then our horizontal axis will still be the scores. So let's do that real quick, and then we'll be done. But let's summarize what we did here. What did we do? We used the classes as the horizontal axis. Again, you could switch those if you wanted, just label everything. And the counts is the vertical axis to create the histogram. Bars are connected because the data is continuous. If you'd prefer to have a relative frequency table or histogram, instead of recording the counts, you would record the percentages in each class. So let's do that real quick and then go from there. So actually, why don't you guys pause the movie? I'll let you try it, or so that you can try it, and then check your work. All right, how'd you do? Awesome. So there you have it. You have done a couple of examples here showing how to make histograms, and I hope that it seems okay, understandable. We'll be having a video about how to do this using JMP and the TI-84 graphing calculator very soon. A positive skew is going to be right-tailed, so it'll look something like this. So you'd have data, maybe it would look something like this. Something like that. Do you see how it would have more of a right tail for the distribution? So this has what's called a positive skew, or right skewed, or right-tailed. And you could have a distribution that looks something like this. I mean, what if you had something that looked like a rectangle? What if all your bars were the same height for each class? Right? This is called a uniform, also called rectangular. We'll talk about this more later. And then the one that we'll talk about a lot is going to be the bell curve. So if you have something along these lines where you have maybe Actually, I'm going to make this one go higher. This one's more symmetric. You've got, I mean, they don't work out perfectly all the time, but you see that there'd be kind of a tail on each side. So this is often called a bell curve. You'll find out all about that soon. Distribution, symmetric distribution. All right, so next up we have time series data. And time series data, I actually pulled this data from the US climate data, and I made a table here. And it's pretty cool because I actually spent several hours today starting to learn JMP. It's really great software. So we're gonna actually, I'll explain, you know, what this data means, but we're going to actually graph this in, again, we'll do another video and we'll graph it in JAM. So I found the average high over the last several years for Oceanside in the first column, and the second column was the actual high temperature for that month for last year. And so why did I do this? I was kind of thinking, you know, it seemed to me like we had sort of a warm winter or a warm year this last year. If it's really different from the average over several years. So let's check it out. Here we go. I'm going to go ahead and let me make this smaller so we can see our data. And we have temperature data and we have months. Okay. And so these you're going to plot kind of as ordered pairs in a sense. It's not really an ordered pair, but you'll have the months going from January to December. So I'm going to abbreviate them if you don't mind. Oop, I'm already off. No, it's okay, as long as I keep them the same now. March, April, May, June. This will be July. And then we'll have August, September, October, and, whoa, a little shaky there, Shannon. And then November. Good so far? Okay. So these are, of course, our months. And on the other side, what are we going to have? We're going to have our temperature. In degrees Fahrenheit. Okay, I think I'm spelling Fahrenheit correctly. Hopefully. So let's take a look at our data. Now, oftentimes this would be data that starting it at 0, I'm not sure would be super effective. All right, so what I'm going to do is I'm going to start, and this is because we have our data values that don't start until 60. So I don't think we would be, skewing the data too much if we didn't start at 0 degrees. Unless you were going to be, comparing data that was from some other climate that was radically different. But we're just comparing these two sets in San Diego. So I'm thinking what we ought to do is start with 60, and then the highest that I see is 73.2. So 60, 65, 70, 75. Okay, let's see how that works. All right, and then what we'll be doing is we're going to need to make another kind of key, because this one we will be plotting in this color. All right, the pink is for this column here. So in January the high was the average high was 63, and then we had February was a little lower. Both February and March I think were 62, right? And then we're back up at 63, and then 65, 67, so 65, and 67 will be about here, and then July was 70, and then 71, 71, so 70, July, and then just a little bit up for August and September, and then October 69, so down a couple, so October will be about here, and then November 66, so 66 will be about here. Oh, and I forgot December. So December is right here. And we'll have 63, so we'll be back down. That's funny. We started with 63 and ended with 63. Okay, I think I did it a little low. All right, so and then what you do is you literally connect the dots. By the way, my fabulous student, I think it was Courtney, taught me if you're using an app called Notability in your iPad Pro, what you can do is if you hold down the pen, it will give you a straight line. Okay, so that's the data for the average highs. Now the recorded high temperature for each month in 2017 was, and I was really kind of blown away by this data because it must have been taken from right by the beach, because I don't know, I'll have to look at it again because it seems awfully low to me. Doesn't it seem low to you? Maybe I was tired when I was gathering this data. All right, so high temp in 2017 in degrees Fahrenheit. So now we are at 61.2. So this one, or maybe I was working with averages. I think I was working with averages. I think this was the average temp. That's what it was. This was okay. It's the average temperature for the whole month is what I did, I believe, for each month. So I'll double check it though and get back to you. So anyway, 60, it's about right here, 61. Maybe a little higher. And then our next value, 60.7. Still too low. So and then we'll have 63.3. So March was 63.3, so that one was a little higher than this one. And April, 65.9. So again, higher than the other. So 65.9 is about here, I think. Nope. And then we are at 65.5 for May. So it's really close to this one here. And then we're at 67.9 in June. And then July will be 72.9. There they go again. And then 72.3, so just a little bit lower. And 73. So it'll be just a little higher than the one from before. And October, 73.2. And November, 68.2. And then December is finally 66.8. So that's what, almost six things higher than the other one. So 66.8 is about here maybe. Didn't seem that much higher. I'm looking at my graph here. Oh, because, so yeah, 66.8. Yep, we're good. Okay, so connecting the dots on these. All right, so here we are. Cool, cool. And so I color-coded it. You'll see when we're in JMP, there'll be kind of a legend down here. So you would take, you know, this information and you would put it down here for your legend, right? So that is it for today. And again, I will be making another video to show you how to do all of these graphs in JMP. Have a fabulous day. Bye.